Good evening. Welcome to the QCIS channel. On this channel, get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight's topic, we're getting right back into surveying, and what we're going to talk about is an introduction to standards. Now, when it comes to design, construction, surveying, or any type of computer-aided drafting, mathematics, there's a set of standards. Now, I live here in the state of Indiana, and when it comes to standards, here with surveying, we talk about accuracy standards. And we're going to get right into it. All right. Just like everything else, move it up. Why is there a whole class focused on data analysis? Well, we can say standards. Because the Indiana Administrative Code, which is the IAC, regulates the level of accuracy that surveyors must adhere to in their work. So when we deal with a standard, we also deal with the administrative code here in Indiana. And the administrative code is given by the authority of state Congress. Again, the administrative code is given authority by the state Congress. And it is also considered a branch of public law. All right, as I move down here. All right. As we talk about the IAC, which is, of course, the Indiana Administrative Code, here we have the Indiana Administrative Code 865, Rule 12. And what it is, Rule 12 is the competent practice, minimum standards for competent practice of land surveying. Now, the rule establishes minimum standards for the competent practice of land surveying as required by Indiana Code, which is IC 2521.5-2-14. And that says the failure of a registered land surveyor to comply with the provisions of this rule may subject the registered land surveyor to sanctions as provided in IC 25-11-1. Correction. Make a correction. The failure of a registered land surveyor to comply with the provisions of this rule may subject the registered land surveyor to sanctions as provided in IC 25-1-11. That's my correction. I said IC 25-11-1. Looks like I had a little dyslexia. I don't. I just read the information incorrectly. It's under IC 25-1-11. Now, given the ultimate responsibility of a registered land surveyor for work done by an employee or subordinate who is exempt from licensure under IC 25-21.5-4-2. The failure of such an employee or subordinate to comply with the provisions of sections 6 through 29 of this rule may subject a registered land surveyor to sanctions as provided in IC 25-1-11. Unless the registered land surveyor did not know and could not, with the exercise of reasonable diligence, have known of the act or omission by the employee or subordinate. Nothing contained in this rule shall be interpreted to give the board authority to take action under IC 25-21.5-10 against a non-registered employee or subordinate of a registered land surveyor. And this is getting into ethics and law. See, a lot of people, when we talk about surveying, we always look at the field applications as if we're going out there with an instrument, a plumb bob, a steel tape or chain, or fiberglass tape and laths of stakes and hubs just to do a stakeout. No, what we're talking about here, we're dealing with the Indiana code. I'm sure all other states have their codes as well. You have to have some standards for surveying to make sure that all of your surveys are done correctly. And without any standards, everything is going to be all over the place. The same thing would apply to a construction project. There are a list of standards. Now, I will tell you about this right now when it comes to standards. Standards, when we talk about meeting them, they're the minimum. So it's the minimum required that you have to meet. So you can go above beyond, but you cannot go below. Again, you can go above and beyond, but not below. And anytime something is violated, it's going to go against these codes. And if you're a licensed land surveyor, you can go to jail, possibly pay a fine, could be criminal or something, or you could lose your license. The provisions of this rule, again, establish minimum requirements. There may be other acts taken or omissions made by a registered land surveyor in the course of rendering professional services to a client, which shall also constitute professional incompetence. Again, the provisions of this rule establish minimum requirements because there may be other acts taken or omissions made by a registered land surveyor in the course of rendering professional services to a client, which shall also constitute professional incompetence. Definitions, abbreviations. Well, we talk about RPA, you'll see that, which stands for relative positional accuracy, which means the value expressed in feet or meters that represents the uncertainty due to random errors in measurements in the location of any point on a survey relative to any other point on the same survey at the 95% confidence level. And that's when we get into error propagations and we start applying the 95% confidence level for error. Measurements for retracement surveys, original surveys, route surveys. The purpose of this section is to prescribe precision and accuracy standards to be used by a land surveyor in conducting original and retracement surveys and route surveys. The land surveyor shall select appropriate equipment and methods and use trained personnel to assure that the acceptable relative positional accuracy specified in this section is not exceeded. Now, the degree of precision and accuracy necessary for a survey shall be based upon the intended use of the real estate. So if the client does not provide information regarding the intended use, the classification of the survey shall be based on the current use of the real estate. Now, classifications of surveys. One must understand there are orders, what we call them classifications. So what I'm going to do is get into the classifications of surveys. And here they are as follows. Okay, classifications of surveys are as follows. Well, we have urban surveys. Urban surveys are performed on land lying within a contiguous within a city or town, except for single family residential lots. Urban surveys include commercial and industrial properties, condominiums, townhouses, apartments, other multi-unit developments, regardless of geographical location. Suburban surveys are performed on residential subdivision lots. Surveys of single family residential lots shall, shall be suburban surveys even if the lot is located in an urban or rural area. Again, we deal with suburban surveys. They're performed on residential subdivisions lots. Surveys of single family residential lots shall be suburban surveys, even if the lot is located in an urban or rural area. Again, we deal with suburban surveys. They're basically performed on residential subdivisions lots. These are surveys of single family residential lots that shall be suburban surveys, even if the lot is located in an urban or rural area. That's urban or rural area. Rural surveys are performed on real estate lying in rural areas that does not otherwise meet the definition of an urban or suburban survey. Now, I had this on a test. The acceptable relative positional accuracies for each classification of survey are as follows. Urban surveys, 0.07 feet plus 50 parts per million. Suburban surveys, 0.13 feet plus 100 parts per million. And we have our rural surveys, 0.26 feet plus 200 parts per million. Relative positional accuracy may be tested by comparing the relative location of points in a survey as measured by an independent survey of higher accuracy or the results of a minimally constrained, correctly weighted least square adjustment of the survey. Now, here are measurements for route surveys. Again, we deal with different types of surveys. So basically, when you conduct a route survey, the land surveyor shall be responsible to use the minimum standards of measurement for urban surveys provided in Section 7 of this rule, except that relative positional accuracy may not exceed 5/10, which is 0.5 feet for a route survey. Also, measurements generally shall be shown on a route survey plat with a number of significant figures representative of the precision of the work. Now, we have minimum standard detail requirements for ALTA and NSPS land title surveys. Now, the purpose is members of the American Land Title Association, known as ALTA, have specific needs unique to title insurance matters when asked to ensure title to land without exception as to the many matters which might be discoverable from survey and inspection and which are not evidenced by the public records. So basically, in order to meet such needs, clients, insurers, insureds, and lenders are entitled to rely on surveyors to conduct surveys and prepare associated plats or maps that are of a professional quality and appropriately uniform, complete, and accurate. Now, you have survey standards of care, survey standards and standards of care. And part of this is going to be measurement standards. So the following measurement standards address relative positional precision of the monuments or witnesses marking the corners of the surveyed property. So when we have relative positional precision, it means the length of the semi-major axis expressed in feet or meters of the area ellipse representing the uncertainty due to random errors in measurements in the location of the monument or witness marking any corner of the surveyed property relative to the monument or witness making any other corner of the surveyed property at the 95% confidence level. So basically, relative positional precision is estimated by the results of a correctly weighted least squares adjustment of the survey. So basically, any boundary lines and corners established or retraced may have uncertainties in location resulting from number one, the availability, condition, history, and integrity of reference or controlling monuments. Number two, the ambiguities in the record descriptions or plats of the surveyed property or its adjoiners. Number three, occupation or possession lines as they may differ from the written title lines. Or number four, relative positional precision. So basically, of these four sources of uncertainty, only relative positional precision is controllable, although due to the inherent errors in any measurement, it cannot be eliminated. So basically, the magnitude of the first three uncertainties can be projected based on evidence. So relative positional precision is estimated using statistics. Now, again, the first of these three sources of uncertainty must be weighed as part of the evidence in the determination of where, in the surveyor's opinion, the boundary lines and corners of the surveyed property shall be located. So, relative positional precision is a measurement of how precisely the surveyor is able to monument and report those positions. So, it is not a substitute for the application of proper boundary law principles. Why? Because a boundary corner or line may have a small relative positional precision because the survey measurements were precise, yet they could still be in the wrong position, i.e., inaccurate, if it was established or retraced using faulty or improper application of boundary law principles. Now, for any measurement technology or procedure used on an ALTA NSPS title land surveyor, the surveyor shall, number one, use appropriately trained personnel. Number two, compensate for systematic errors, including those associated with instrument calibration. And number three, use appropriate error propagation and measurement design theory. And that's by selecting the proper instruments, geometric layouts, and field and computational procedures to control random errors such that the maximum allowable relative positional precision, which is outlined in section 3EV, is not excluded. Also, the maximum allowable relative positional precision for an ALTA NSPS title land surveyor is 2 centimeters or 0.07 feet plus 50 parts per million. And where did you see that number 0.07 feet? I can tell you where I saw that number. That was in an urban survey. That was the accuracy, 0.07 feet plus 50 parts per million. And that's based on the direct distance between the two corners being tested, because it is recognized that in certain circumstances, the size or configuration of the surveyed property or the relief, vegetation, or improvements on the surveyed property will result in survey measurements for which the maximum allowable relative positional precision may not be exceeded. Now, if the maximum allowable relative positional precision is exceeded, the surveyor shall note the reason as explained in section Dot B, other survey or accurate standards. We have topographical surveys or topos. So I will go over for you for the positional accuracy. This is the positional accuracy. So the following positional accuracies are provided as a guide for topographical surveys. Now, what you have are the accuracies for vertical and horizontal, and you deal with contour lines of 1, 2, 4, 5, and 10-foot intervals. You have floor elevations, you have spot paving elevations, ground elevations, invert elevations, and you have well-defined planimetric features. And here are all the accuracies that you have for vertical and horizontal. And the positional accuracy is given at the 95% confidence level. Then we go down to construction surveys for the relative positional accuracy. And again, the positional accuracy is given at the 95% confidence level. But now, the following relative positional accuracies that we have for construction surveying are, again, as a standard provided as a guide for the placement of stakes and other materials utilized to mark the location of proposed fixed works. And what you have are two columns, which they're in feet and meters of horizontal positional accuracy and vertical positional accuracy. And then when we deal with construction, you're going to use stakes, cut and fill. They're called grade stakes. So you're going to have rough grading stakes. That's right. You see a F, that's a fill. You see a C, that's a cut. Those are grading stakes. Then you're going to have subgrade redhead stakes. You're going to have finished grade blue top stakes, building offset stakes, sewer offset stakes. That's right, sewer offset stakes, waterline offset stakes, hydrant offset stakes, street lights, and curb offsets. Again, you see the columns, horizontal and vertical. The accuracies are meters and feet. Moving on. Then we get in what we call GIS, Geographical Information System Surveys. And we have the minimum horizontal accuracy. So basically, for GIS, the horizontal accuracy is based on the American Society of Photogrammetry and Remote Sensing, known as ASPARS, standard for Class 2 and reported in agreement with the National Standard for Database Accuracy. So the NSS, or I call it the NASDA, horizontal positional accuracy statistic, is at the 95% confidence level and is determined by multiplying the root mean square error, known as RMSE, of the data set by 1.7308. And if you look at what's acceptable, you have the columns, you have the base mapping scale of LIS and GIS, and you have the positional accuracy statistic of survey data. And here are your maps. And here is your accuracy. Now, when we deal with geographical information surveys as well, we have a minimal vertical accuracy. So the vertical accuracy is also based upon the ASPARS standard for Class 1 and reported in agreement with the National Standard for Spatial Data Accuracy. So the NASDA vertical positional accuracy statistic at the 95% confidence level is determined by multiplying the RMSE, which is the root mean square root error of the set by 1.96. And moving on, we have the base mapping control for contours, and we have the accuracy statistic of survey data. And there you have it. When it comes to surveying, you have different types of surveys. Again, they're urban, they're rural, there's GIS, there's route, there's construction, there are topographical surveys, there are subdivision surveys. Well, when you go out in the field, you have to follow those standards. Now, again, those standards are based on giving the minimum. So you can do more than the minimum, but you have to at least meet the minimum of what that standard requires. And when it comes to surveying, you have your parts per million, you have your significant digits. You also have, if you're doing a traverse, you have your closure. There's the least squares method. And least squares method can be a complicated method because it is very mathematical and you have to deal with a lot of matrices. And those matrices can get really, really long by hand. So there's a software out there called Wolfpack that'll do it for you. And again, there are rules that you must follow when you deal with surveying. And if you don't follow those rules, you could lose your license. So if you want to go into surveying, one thing you need to understand is this. Most of us, we think it's just going out in the field, setting the instrument up. You have a rod person setting up the rod or the prism. We used to have a 3-person crew, somebody that was recording all the data. Basically, it's a party chief, and you have a surveys helper, which is a survey technician. You have to know a little bit about CAD when you're doing these maps, because you also have ALTA surveys, and ALTA surveys have to be detailed because you're dealing with titles and insurance companies, and it can get a little hairy when you're dealing with real estate, because when somebody's moving into a piece of land, they need to know exactly what's on that piece of land, where all the property markers are. This is why you have to be very accurate when you're doing ALTA surveys. All surveys, I'm going to say this, will have error. It could be from the instruments not being calibrated. It could be observation. It could be even a temperature. Like if you're taking the steel tape out there, the standard temperature is 68 degrees. Well, you could be reading 100 when you're actually reading 100.20. And if you have sag in the tape, because nowadays they're using fiberglass tapes for some distance measurements. They have 300-foot fiberglass tapes, which they used to have links. I mean, an actual chain, which is, I believe it's 66 links, 100 feet. And they went to a steel tape, which was 100 feet. And there are different error corrections for your triangulation, for your coordinates, because it's very important that when you go out and do any type of surveying, you need to be accurate. And when we deal with, let's say, GNSS, that's your global navigation system. When you hear anything about major axis and minor axis, the long side is always your major axis. The short side is your minor axis. We're dealing with ellipses. Now, when you have your long ellipsis, I'm going to tell you this. you need to go out and fix those ellipses. Why? Because the longer your ellipse is, the more area you have. Want to keep everything small. You want to try to get it as close to nil as possible. But in the end, comes to surveying. To be accurate, you must follow minimum standards. Here in Indiana, look under 25. But make sure in any state, follow your standards and specifications. Because surveying is there to provide for the public. And that concludes this topic on introduction to standards. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some social and some political content, you can check out my main channel, the 411 Talk Zone radio show channel, also on YouTube. Now, when it comes to my videos, whether it's the 411 Talk Zone radio show or the QCIS channel, once I upload all the videos to my YouTube channel, I also post them on my Twitter page. Now for the QCIS page, the QCIS channel, since it's more of an educational channel, I also post that channel on LinkedIn. So again, conclusion of all of my YouTube videos that I record from both channels, post them on Twitter and then my QCIS channel. I also post it on LinkedIn. And once again, thank you for viewing this content regarding surveying standards, introduction to standards from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. You all have a wonderful and gracious evening.